Hello everyone, we are group number 27 and my team members are Bibek, Nikhil, Pawan and myself Alan. For this assignment, we are making an analysis of voice data to identify people with Parkinson's disease and healthy patients using data scrambling and descriptive analysis. Parkinson's disease is a progressive neurological disorder characterized by a gradual deterioration of motor functions. It is caused by the degeneration of dopamine producing nerve cells in the brain, leading to symptoms such as tremors, rigidity, bradykinesia, and postural instability. Beyond its physical manifestations, Parkinson's can also impact vocal patterns and various other non motor functions. Early diagnosis and intervention are crucial for effective management and improved patient outcomes. In our pursuit to enhance diagnostics, we explore the intricate correlations between voice variations and the identification of potential Parkinson's disease patients. Early diagnosis and interventions are of paramount importance in managing Parkinson's disease effectively. Timely identification allows for the initiation of therapies and interventions that can alleviate symptoms, enhance motor functions, and improve overall well being. The quest for early diagnosis and improved treatment outcome drives our research, where we investigate the intricate interplay between voice variations and the identification of potential Parkinson's disease patients. Through rigorous analysis and advanced methodologies, we endeavor to contribute to the enhancement of diagnostic tools that can ultimately make a significant impact on patient care and management. I will now hand over to Nikhil, who will explain the basic methodologies we performed.
Thank you, Fallon, for the introduction. Our analytical journey embarked with the acquisition of raw data, requiring a rigorous regimen of data wrangling, employing a suite of powerful data manipulation tools, including the Pandas, SciPy, Matplotlib, and Seaborn libraries. We meticulously curated, structured, and probed the dataset. This intrinsic to our data preparation was the meticulous treatment of missing values, a measure to ensure the integrity of our analysis. Following this, data went under data underwent a transformative process, resulting in a refined dataset featuring 29 distinct variables. Among these, 26 variables encapsulated voice samples across a diverse spectrum of acoustic ranges. A pivotal juncture in our exploration entailed the execution of t-test through the utilization of Python, thereby revealing profound distinctions with the 26 vocal variables. The ensuing insights were artistically depicted via box plots, elevating our understanding of the inherent data distributions. Drawing from our rigorous analysis, we identified a core set of five variables. These variables exhibited a remarkable potential in demarcating individuals with Parkinson's disease from their healthy counterparts. The ramifications of this discovery hold immense promise in augmenting early stage diagnostic methodologies and subsequently enhancing patient prognosis. Next, Vivek will explain the code execution to show the analysis of data.
Thank you, Nikhil. I'm Vivek. I will explain about the codes. We use different libraries to analyze those data. I'm sharing my screens. I think you will able to see my screen. So basically, what we did is we use four different libraries. That's Pandas, SciPy, Matplotlib, and C1. So we have the data that had been provided by our lecturers. So we render the data using pandas and we clean those data. So there are no column titles within the data, but they have been provided those column titles separately. So we use data.column to add the columns for respective data. So we distinguish those variables or columns into the must variables of interest in the code. So the salient variables will describe those variables who involved in the analysis of the data. So what we have done in this project is that we have calculated the mean and standard deviation according to the PD and the healthy persons. So what we have done is that we have distinguished PD group and the healthy group that has been denoted by 1 and 0. and we calculate the mean and standard deviation. Then we find out the correlation as well and plotted those outputs in the graph and the heat map as well. So basically what we have done is try to analyze the Parkinson's disease data. So I think this much for my part, but I will show you the output as well. So this is the output that we have done, we have generated through the analysis. So I like to hand over the presentation to Pawan.
Thank you, Vivek, for explaining the code so wonderfully. All right, so based on the code which we executed and the data scrambling and everything, our findings are like, in summary, our collaborative endeavors have enabled us to navigate the intricate tapestry of voice variations as a diagnostic conduit for Parkinson's disease. The fusion of scrupulous data wrangling, advanced statistical methodologies, and per- perspicacious visualizations culminated in the unveiling of pivotal variables with the potential to redefine the landscape of Parkinson's disease diagnostics. We unearthed 5 variables that demonstrated the most pronounced mean differences in comparison to the remaining 26 variables. Those are jitter as average absolute differences between jitter cycles, which the mean difference of this one is 0.655, and shimmer as 11-point amplitude perturbation quotient. The short form is APQ11, and this has a mean difference of 1.772. And the third one is shimmer as average absolute consecutive differences between the amplitudes of shimmer cycles. This has a positive mean difference of 0.322. And the fourth one is maximum pitch with a negative mean difference of 33.810. And the fifth one is pulse by number of periods, which also has a positive difference of 13.981. So based on this, we observed that whenever the mean difference is positive, the values in the PD group were higher, and whenever it was in negative, the values in the healthy group were higher. So based on these mean differences, we were able to conclude that whenever the higher values were in the PD group, it's most likely that the patient can be diagnosed with the Parkinson's group, and whenever the mean difference was in negative, that means the individual might be a healthy person. These variables emerge as potent tools for distinguishing Parkinson's disease patients from their healthy counterparts. In conclusion, our exhaustive voyage through data analysis has illuminated to the profound role of voice variations in the identification of potential Parkinson's disease patients. Through the meticulous orchestrations of data wrangling, advanced statistical methodologies, and insightful visualizations, we have unveiled a constellation of 5 pivotable variables with the potential to discern individuals grappling with Parkinson's disease. This breakthrough stands to revolutionize early stage diagnostics, ushering in a new era of more effective patient care and management. Our findings underscore the potency of interdisciplinary collaboration in unraveling intricate medical challenges and propelling the frontiers of medical research ever forward. Thank you.